Hello everyone, I'd like to welcome you to our ChromLab Introduction webinar. My name is Benjamin Nickel and I'm one of the chromatography specialists from Bio-Rad Technical Support. For today's presentation, we'll be using version 3.1 of the ChromLab software. ChromLab is a software package that works with the Bio-Rad NGC system to develop, organize, and run chromatography methods, as well as collect and analyze the resulting data. The software is designed to make operating the NGC system and analyzing the data easy and intuitive. The title of today's webinar is ChromLab Software. Learn the basics from the experts. The goal of today's webinar is to provide you with the necessary information to navigate and use the software. Now today I'll introduce you to the major software features, after which you'll be able to operate your NGC in manual or method mode and run a basic analysis of the resulting chromatograms. For those of you who may be interested in a more detailed discussion on the tools available for data analysis, we'll be releasing a separate webinar in this series that will specifically focus on the software evaluation tools. Today's presentation is going to cover the following topics: getting started with the ChromLab software, after which I'll move into a discussion of the NGC system controls for operating the system in manual mode, followed by a discussion of the method editor, which is used to set up a method run. And finally, I'll provide an introduction to the evaluation tools used in the software. Now let's begin by switching views to the home screen of the ChromLab software. Now in order to run your NGC system with the software, you want to first make sure your connection is established to your NGC. When the software is properly connected, a message will be displayed to indicate that connection is established. Now if no NGC is detected, the software will display a message that says Connect to System. If you see this message, make sure the NGC is powered on, then click on that Connect to System message. This will bring up a window which allows connection to any detected NGC systems or connection through a system IP address if your NGC is networked. Now you'll notice the software is divided into three main sections. You have your System Controls section, which is used for calibrating and operating the NGC in manual mode. Your Method Editor section, which is used for method development, review, editing, and method initiation. And finally, your Evaluation section, which is used for post-run data analysis. You'll also see that links are provided at the bottom here for quick access to the 5 most recently completed runs, methods, or files that have been analyzed. For any of these links, if you simply move your pointer over the link, it'll provide you with additional details about that file. Now let's take a closer look at the System Controls section of the software. If you click on Manual Run, you'll be taken to a new tab in the software which is labeled System Control. And you can see the tabs shown here at the top. Within this tab there are 3 main viewing areas. In the bottom right is the fluidic scheme. This allows visualization and manual control of the modules associated with the NGC system. In the lower left is your run log. This provides a running log of all the system operations which occur during a manual run. These log files are saved along with the manual run data to aid in record keeping and review. And finally, we have the chromatogram display, which shows the detected data in real time as the system is running. And the fluidic scheme display should provide a visual representation of all of the modules which are associated with your NGC system. If you have modules on your system that are not represented, the fluidic scheme can be easily modified as necessary by going to the Tools menu here at the top and selecting Change Fluidic Scheme. This is going to bring up your fluidic scheme selector. To the left of this window, the fluidic scheme selector allows quick selection of schemes that are matching the available pre-configured systems from Bio-Rad. You can click on any of these schemes and you can see that the fluidic scheme will be updated to show a diagram of the modules associated with that specific scheme. Now if you have modules that were added to the pre-configured system, a custom fluidic scheme can be created. To do so, you would hit New at the bottom of the screen to create a custom scheme. This will open up our fluidic scheme editor. When modifying the fluidic scheme, you'll see that the editor is broken into 5 sections. You have your pumps, the sample inject, columns, the detectors, and the sample collection. You can hit Edit under the section that needs to be changed. And by dragging this configuration up or down, the software is going to allow you to scroll through and choose from any of the supported configurations. So for example, we can scroll through here and we can select a system that adds 2 inlet valves to our system pumps. And we'll hit Accept. Once our fluidic scheme is configured to the desired configuration, we can hit Save at the bottom to save the custom fluidic scheme. Now it's going to prompt us for a name for our new configuration. And once we name our configuration and hit Save, you'll see that the new name appears under the custom schemes, under the fluidic scheme selector. We can highlight that and hit Select to make that selection. Now, after selecting our fluidic scheme, users that have a more advanced system that use multiple inlet, outlet, or column switching valves will be prompted to check the mapping of the fluidic scheme. This allows mapping of each module in that fluidic scheme to its relative position on the NGC frame. In our situation, we're being prompted to check this because we've added 2 inlet valves to our system pumps, inlet valve A and B, and it's asking us to make sure the correct inlet valve is assigned to the proper location on our NGC frame. This is important for the proper differentiation between the multiple modules of the same type. Now, this same tool can be accessed at any time using the Tools menu in the System Controls tab. Now that our fluidic scheme has been updated and is correct, you'll see that there's a real-time status and reading from each of the modules shown within these module information boxes. By clicking on any of the modules within the manual mode, you'll get a module control box that will open. For example, if we click on the multi-wavelength detector, you can see we can turn lamps on and off from the control box. We can choose the detected wavelengths that we're monitoring, and while the system pumps are running, we can even zero out the baseline. Now, for the lamp options, it is always advised if you are not using your NGC for extended periods of time to make sure you turn your lamps off to extend the life of your lamps. Now we can also click on our system pumps, and we can see under the system pumps we can select the flow rates, we can specify if we're operating in an isocratic or a gradient flow, we can set flow durations, and we can even set pressure limits. So as an example, let's go ahead and we're going to start a flow on our system at 1 milliliter per minute by making the correct flow rate and hitting start. Now what you may have noticed is after I've hit start, ChromLab is going to display the active flow path in green whenever a buffer is moving through the system. So for example, in this system here, we have, and I'll move the box out of the way here, we have our buffers being intaken through inlet valve 8 connected to our system pump A. The buffer moves through the system pump to the injection valve, over to our column, through our multi-wavelength detector, past our biofrac fraction collector, and is being directed to our waste port. Now what you may also see is that the run log has now been updated with the details of the manual run up to this point. And whenever any changes are going to be made, the run log will document those changes. So for example, let's go back over here and we'll change our flow rate to 5 milliliters per minute. Let's also go ahead and we're going to start collecting fractions on our biofrac. And after I hit start to start collecting the fractions, you'll see that the active flow path has now been redirected, so the flow is now moving to our fraction collector to collect those fractions. And you'll also notice that all of the changes we've made so far have now been updated in our run log. And we can also look up at our chromatogram, and you'll see there are tags showing the events that have occurred so far in our manual run. Within the chromatogram, we can also show errors, annotations, and fractions that have been collected during the manual run. The fractions being collected are shown here in blue. We can turn off any of those displays of the fractions, events, errors, or annotations simply by deselecting the box shown over here on the right under the legend. If you'd like to add an annotation to your chromatogram, you can simply click on the annotation button at the top, and you can drag that vertical bar to the desired location within your chromatogram. And now we can just type whatever we would like to label our annotation. If an annotation is applied that you later wish to remove, you can do so simply by clicking on that annotation and using the delete function. Now, to aid in the visualization of the chromatograms while the pumps are running, you can use the autoscale feature to autoscale the wavelength traces. The autoscale features are located here at the top of the software. You'll have three options: autoscale off, autoscale each, and autoscale all. The autoscale off feature is somewhat self-explanatory. This turns off any autoscaling from the chromatogram. Autoscale each will adjust the scale of the recorded wavelength traces independent of all other wavelength traces. And autoscale all will adjust the y-axis to the scale of the highest peak and maintain the same scale for all wavelength traces that are being monitored. To help simplify the display data, display of individual traces can be turned on or off in the chromatogram view. We can do this by using the arrow shown over here in the legend to expand the legend box. Simply checking or unchecking the box next to the desired traces will turn the displays on or off. So in this situation, we can go ahead and uncheck the box next to the 255 nanometer trace, and you'll see that that has now been removed from our chromatogram. When unchecked, the software still captures the data for that trace, and it will allow the display to be turned on at a later time if desired. In this box, you also have the option of manually adjusting the minimum and maximum for the y-axis scale of the various traces. You'll see that shown over here. For the wavelength traces, the scale can only be manually adjusted when the autoscale features are off. Now, when we're viewing multiple traces, you can adjust the displayed y-axis by simply clicking on that y-axis to toggle between the active traces. So here we can go to %buffer B concentration, click again, it takes us to the 200 nanometer trace y-axis, and one more time brings us to conductivity. You'll notice that there is a y-axis scale provided on the left and the right of your chromatogram. For zooming in on a specific area of the chromatogram, you can simply left-click on that chromatogram, and you can drag a zoom box over the area of interest. Now, multiple zoom layers can be applied for fine-tuning the zoom on your chromatogram simply by dragging another zoom box to refine that selection. To unzoom, there's going to be two options that are made available, and you can access these by right-clicking on the chromatogram. You'll see the undo zoom, which takes you back one zoom level if multiple zooms have been performed. Or you can use the reset zoom function, and this will take us back to the default view. The reset zoom is also available at the top of our screen here. So at this point, I'm just going to go ahead and shut off the system pumps. And now once we've completed our manual run, you can save the run file by using the Save button at the top of the screen. If you wish to clear the manual run data and start a new manual run, you can use the Clear option, which is shown here. If you select Clear and you have not saved the manual run data, it'll prompt you to ask if you want to continue to clear the data before saving. If you wish to continue to clear it, just hit the Continue button. The Clear will remove the chromatogram from the manual run to start fresh. It'll also remove anything that has been logged into your run log. And there are a few additional features I wanted to point out that are accessible through the System Controls tab. And these are the calibration features, flow rate converter, and the point-to-plumb features that have been worked into the software. The calibration features I've mentioned can also be launched by selecting calibration from our main menu. So if we go back to the main screen, you'll see a calibration box here for quick launch from this screen. If in the System Controls tab, the calibration functions can be found under the Tools menu. The calibration features allow you to calibrate the system pressure, you can calibrate the flow rate, the pH monitor if you have a pH monitor on your system, or the conductivity monitor. You'll see that step-by-step instructions are provided within the calibration window to walk you through the calibration functions. And the flow rate converter tool that I mentioned, also accessible through the Tools menu. This is a calculator that is worked into the software that allows conversion between linear flow rates in centimeters per hour to volumetric flow rates in milliliters per minute or you can actually do the reverse calculation. To do the conversion, you will have to provide the software with the diameter of the column that you are using. And finally, the point-to-plumb feature that I mentioned. This is a feature in the software that is designed to help easily identify system connection ports when plumbing the NGC. If you go into the Tools menu, you can access the point-to-plumb window by selecting Point to Plumb. Within this window, you can simply click on any area of the flow path, and you'll see when you're working with your NGC that this will activate LEDs on the NGC that direct you to the proper plumbing connection ports. This helps easily identify the appropriate ports if you have to replumb your system for any reason. Given the format of this webinar, this feature is difficult to show in action. However, when you return to your NGC system, I would encourage you to play around with this feature. At this point, let's go back into our main software menu, and now we can discuss the method editor functions. The method editor allows you to create methods from the very beginning. It also allows you to edit an existing method or use a method template. For this webinar, we're going to be working from an existing template in the software. When devising a new method, it's helpful to start with a predefined template, and that allows you to simply edit it to suit your application. So now if we click on Open Template, this will bring us into a new pop-up window, and you'll see that within this window, the templates are organized based off of the chromatography technique shown here on the left. Each template will show a quick reference schematic to the buffer gradient flow for that particular template. You'll also see that there's a Notes tab provided for each template. Within this tab, you'll find a method description, information about the columns and samples to use with the template, as well as method parameters and the modules and devices that are required for running the method. For this presentation, we're going to go ahead and open up the anion exchange method. And this brings us to a new tab labeled Method Editor. In the Method Editor tab, you'll see that the methods have a phase-based organization to them. Individual preconfigured phases can be accessed using the phase library. The phases that have been incorporated into your specific method are going to be listed here under the method outline. Now, phases can be added to the method outline by simply dragging a phase from the phase library over to the method outline. So for instance, if we wanted to add a column wash step into our method, we simply grab it and drag it over to the desired location. If you have phases in your method outline that you wish to remove from that outline, you can simply right-click on that phase and use the delete function to remove it. Now, it's important to note that the exact parameters you're going to see in each of these phases is going to be dependent on which modules you have specified in your fluidic scheme. So depending on the system you're using, you may see the options displayed will vary from what you see on my screen. Now, every method is going to begin with the Method Settings section located here at the top of our method outline. All individual phases are added underneath the method settings. The method settings will define the properties of the methods that will remain constant throughout the entire run. The exact options that are indicated in your method settings are going to be dependent on the modules that you've selected in your fluidic scheme. So a good place to start is just to make sure that you have the appropriate fluidic scheme set on your system. You'll see the diagram of the fluidic scheme down in the lower left corner of the method editor. You can make changes to the fluidic scheme simply by using the Change button here where it says Fluidic Scheme Change. Selecting Change is going to bring up the fluidic scheme selector we've previously been introduced to at the start of this webinar. You see all fields are pre-populated when working with these templates, but they can be modified as needed. One of the things you're going to want to check is you're going to want to ensure that the column type that is listed will specify the column you're using on your NGC system. For the column type, there is a drop-down menu provided. Within this drop-down menu, this will be pre-populated with the details for all the Bio-Rad pre-packed columns that are available for a specific type of method. And for convenience, many of the GE pre-packed columns will also be listed for selection simply by expanding the selection tree down here at the bottom. Now you can also create a custom column for if you're using hand-packed columns or pre-packed columns that may not be listed simply by selecting custom. Now for the columns that are listed in the drop-down menu, they will already be defined with the appropriate column properties, which will include back pressure limits and column volumes. To display the full column properties, you'll just simply select Column Properties button. Now if you're using fraction collectors with your method, you're going to want to make sure that you also configure the fraction collector by using the Configure button shown here. This will allow you to select the appropriate rack type that you're using for your fraction collection, as well as specify the size of the fractions that you wish to collect. One of the features of the software that I want to point out is a button that says Control the Flow to avoid overpressure, shown here. This feature allows the software to automatically decrease the flow speed if the back pressure that is being detected by the system is nearing the maximum specified back pressure limit for a column. This is useful for protecting your columns from being damaged due to unexpected back pressure increases. Now after setting the method settings, the individual phases within the method can be customized as needed. As you go into each phase of the method, you'll see that these phases can be adjusted for column volumes being run, as well as you can add different flow schemes. So if you want to add an isocratic or a gradient flow to that particular phase, you can do so. As you click through the individual phases of the method, you're going to be presented with different options depending upon the phase and the selected fluidic scheme. You should always check through all of your phases within your method and make sure that all the parameters are set appropriately before saving and then running your method. At the bottom of your Method Editor tab, you'll find a method schematic showing the % buffer B composition versus volume. Within this scheme, you're going to see nodes. The nodes are defining a break in the individual phase of the method or a change in the flow rate within the method. Each of these methods are adjustable by clicking on the nodes, and you can actually, if you click them, you can drag the nodes as far as the length of a particular step or % buffer B composition. Any changes made by dragging the nodes will automatically be reflected in the method outline at the top. One of the features I want to introduce you to at this time is the scouting features that have been incorporated into the software. This feature is accessible using the Scout button, which is located here at the top of your screen. Scouting is designed to help optimize a purification method by setting up a series of sequential runs which use the same method but alter a single method variable between the runs. And this allows observation of how that variable influences your specific separation. Now, provided that the appropriate modules are available on your NGC, the software is going to allow you to scout on flow rate. You're going to be able to scout % buffer B composition, step duration, the pH, columns used, or the sample volume that's being loaded. The scouting wizard will walk you through the steps needed to set up a series of runs for scouting these particular variables. Now when you're finished defining your method, you can use the Save As button to save the method. After saving, you can use the Start Run button when you're ready to initiate that method run on your NGC. Now the final section of the software that I wanted to briefly touch on today is the Evaluation Tools section. So we're going to go back to our home screen here. You'll see the Evaluation Tools section of the software. This is used for post-run data analysis. Now, if you're a previous user of Unicorn or DualFlow, and if you wish to review some of your previous data sets in the ChromLab software, you can do so by going to the File menu and using the Import features. You want to make sure you import your data sets before going into the Method Editor. Now, to enter the Evaluation Tools section from the main menu, you can use the Open Run Analysis button here. This will bring up our Open Run Analysis window used for selecting the individual files. You'll see the files will be saved under the individual projects you specified at the time of the data collection. The individual runs within each project can be organized based off of the name, the start time of the run, the end time of the run, or the method that's being used. Now, each file is going to show you a preview of the chromatogram to aid in the proper file selection. Now, once you've selected your desired run file, and we'll select this Scout PH7, and we're going to open that file. We'll be taken now to a new tab, which is labeled Evaluation in the software. In this section, you'll see your chromatogram is displayed, as well as tabs that are available here at the bottom for changing the displayed traces and looking at collected fractions. From the Run Traces tab, you can turn the individual traces on or off to customize the display by simply checking the boxes next to the individual trace. So, for instance, here, let's go ahead and shut off our 215 nanometer trace, and we're going to shut off the display of the percent buffer B flow. So now all we have shown is our 280 nanometer trace. The software allows you to integrate the individual traces, allows peak integration using the peak integration button shown here at the top. Now after we select the peak integration function, you'll see that there is a new data table that opens up at the bottom that's labeled peaks. It's within this tab that you'll be provided with the individual information for each peak that has been detected and integrated. You'll find there are many tools that are available within the Evaluation tab to help you format and analyze your chromatograms. For today's presentation, we will limit our discussion of the evaluation tools to this quick introduction. However, for a more detailed presentation of the evaluation features in the ChromLab software, you can see our second webinar, which is going to be titled NGC ChromLab Software: Learn Data Evaluation Tools from the Experts. Now at this time, we've covered the necessary information to get you started with the ChromLab software. We've reviewed the system controls, we've talked about the method editor, and we've provided a brief introduction to the data evaluation tools. As you begin to work with your NGC system and the ChromLab software, you're always welcome to contact us at Bio-Rad Technical Support by phone or email should you need assistance. I've placed the phone number and the email address on the screen for you. Thank you for your attention and for viewing our webinar titled NGC ChromLab Software: Learn the Basics from the Experts.